Hello everyone, welcome back to my channel. In this video, we're going to discuss about the concept of volume strength of hydrogen peroxide. Now, if you ever go to any chemist shop and buy the bottle of hydrogen peroxide, you will see that on its label, something like this 20 VOL is written. Something like this is written on the bottle of hydrogen peroxide. Now here on this image, 20 alphabet, 20 word is written, right? Sometimes you might see that it might be written like this 10 VOL, or it might be written like 5 VOL or 2 VOL. Now what is the meaning of this thing? That is actually the volume strength of hydrogen peroxide. But how do we decode this term, this integer into VOL? How do we decode it? Right? That is very important for us. So basically, if we say that x VOL H2O2 is there, right? If x is the volume strength of H2O2, what is the meaning of this thing? That means that at STP conditions, x liter of O2 is obtained from 1 liter of H2O2. Simple. That is the meaning of x volume strength of H2O2. So if we say 10 volume strength of H2O2, that means 10 liter O2 is obtained from 1 liter of H2O2. So if we say here 20 volume strength of H2O2, that means 20 liter of O2 is obtained from 1 liter of H2O2. This is a simple definition of volume strength of hydrogen peroxide. But the conditions are STP conditions. The conditions must be STP conditions. Now important thing is to relate the concept of volume strength with concentration term of H2O2. Let's say molarity. So we'll try to find the formula of volume strength. Let's say X is the volume strength of H2O2. So we'll try to find what is the relation between X volume strength and molarity of H2O2 in between these two terms, right? So let's see. Now if we have the balanced equation of H2O2, say simply H2O2 is a relatively unstable molecule. So if we keep it in the open, some amount of H2O2 can easily decompose or dissociate to release O2 gas. And if you look at this reaction, it is a balanced one, and here 1 mole of H2O2 easily gives us half mole of O2 at any condition, right? So if we conduct this reaction at STP, we know at STP what happens. At STP, 1 mole of any gas is equal to 24 per liter. This is a standard thing, right? This is a standard thing that 1 mole of any gas at STP conditions is equal to 22.4 liter, right? Now here H2O2 is 1 mole according to stoichiometry, and O2 is how much? O2 is a gas which is half mole. So if 1 mole is 22.4, then half mole is how much? It will be 22.4 by 2, which is 11.2 liters. So I can say that 11.2 liter O2 is obtained from 1 mole of H2O2. Can I say this thing? Yes, that 11.2 O2 is obtained from 1 mole of H2O2. And how much is the mass of 1 mole of H2O2? Its molar mass. It is how much? It is 32 plus 2, which is equal to 34 gram. So 34 gram is the mass of 1 mole of H2O2. So we can say 11.2 in the statement. 11.2 liter of O2 is obtained from 34 gram of H2O2, right? So if X is the volume strength, let's say X is the volume strength of H2O2. So it will give us what? If X is the volume strength of H2O2, it will give us X liter of O2. So if 11.2 liter of O2 is obtained from 34 gram of H2O2 according to the balance reaction above, then X liter O2 is obtained from how much H2O2? This much. 34x divided by 11.2. Simply done by unitary method. Now since we have assumed that X is the volume strength of H2O2 sample, that means what? Since we have assumed X is the volume strength of H2O2 sample, that means X liter O2 is obtained from 1 liter H2O2. This is what we have assumed. Now go to the statement A and statement B. Statement A says that X liter O2 is obtained from 34x divided by 11.2 gram of H2O2. And statement B says that X liter O2 is obtained from 1 liter H2O2. So if we correlate these two equations, these two statements A and B, So what do we conclude? We conclude that 34x upon 11.2 gram is the mass of 1 liter of H2O2, right? This is what do we conclude, that 34x upon 11.2 gram is the mass of 1 liter H2O2 solution, right? So if this much grams of H2O2 is present in 1 liter solution, and if we try to convert it in the number of moles, then what do? We simply divide this mass by molar mass of H2O2, and molar mass of H2O2 is 34. So here if I divide it by 34, what do we get? We simply cancel it, and what do we have? Now we have x by 11.2 moles of H2O2 in 1 liter H2O2 solution. So that means how many moles are there? The number of moles are x upon 11.2. These are the number of moles, and how much is the volume? Volume is 1 liter. We know molarity is equal to what? Molarity is equal to number of moles per unit volume in liters. And if volume is equal to 1 liter, then molarity is equal to number of moles, right? We can easily understand here. If I put volume is equal to 1 liter, molarity will become equal to number of moles. The same situation is here for us, that volume of H2O2 is how much? 1 liter. So in 1 liter H2O2, how many moles are there? X upon 11.2. That means what is the molarity of H2O2 solution? The molarity of this H2O2 solution is x upon 11.2, right? So this is the final equation and final formula you need to remember, that molarity of H2O2 solution is x upon 11.2, where x is the volume strength of H2O2, right? This is what we have. Now sometimes in the questions what they usually ask us the strength, calculate the strength of H2O2 in different terms. If they ask us that calculate the strength of H2O2 in the terms of molarity, then directly apply this formula, that is x upon 11.2. If they ask us that calculate the strength of H2O2 solution in terms of grams per liter, in terms of grams per liter, in that case simply you have to do this thing, you have to calculate the molarity by using the above method, that is x upon 11.2, and multiplied by molar weight. Molar weight of what H2O2 is 34 grams. So simply multiply molarity with 34 and you will get the strength in terms of grams per liter, right? Now I hope you understood the concept properly. So let's try to apply this concept in the form of a question. Now this question is given to, the question is asking, you are given 20 V H2O2 solution. The volume strength of H2O2 is given to 20 V, and we have to calculate the strength in the terms of normality, grams per liter, molarity, and percentage. In these four terms, you have to calculate the strength of H2O2, right? Before going to the solution, which definitely I will be explaining in just few seconds, I hope you will try to solve this question by yourself, and once you are done with it, then you will try to relate your answers in your notebook with the answers given in this video, right, and the concept in this video. So let's go to the solution. Now 20 V is the strength of H2O2 which is given to us, right? So we can easily find the molarity. Molarity will be what? Molarity will be x upon 11.2. X is here 20, this is x. So 20 upon 11.2, we get 1.78. So the solution is 1.78 molar. This is the molarity. So we obtained the answer third, right? Molarity is obtained. Next we need to find the normality. Now normality is basically what? Normality is equal to molarity into n factor. This is the formula which we know. And normality of H2O2, normality of H2O2 is 2. You should know this thing. If you don't know, then write it down. Normality of H2O2 is 2. So simply, sorry, n factor. I have just made a mistake. N factor of H2O2 is 2. Okay. N factor of H2O2 is 2. So normality is equal to what? Molarity into n factor. And molarity is 20 upon 11.2 into n factor is 2. So finally we obtained 40 upon 11.2, which comes out to be 3.56 normal. So the solution is 3.56 normal. Next is calculate the strength in the terms of grams per liter. And this is what I have explained just above. In the terms of grams per liter, the strength is molarity into molecular weight. Since we have calculated the molarity, which is 20 upon 11.2, and if I multiply it by 34, which is the molar weight, we obtained answer in terms of 60.52 gram per liter, right? Next, finally, we need to calculate the strength in the terms of percentage. Now, the percentage which is asking us here is basically what? The percentage is weight by volume percentage. Now, what is the weight by volume percentage? Weight by volume percentage formula means weight of solute upon volume of solution into 100. This is the basic meaning idea about it. So if somewhere it is written like this, suppose karo, let's say, suppose somewhere it is written like 10% W by V. If something like this is written somewhere, 10% W by V, that means 10 gram of solute in 100 ml solution. This is the meaning of this statement. Understood? If somewhere it is written like this, that 10% W by V, that means 10 gram of solute in 100 ml of solution. So what is the question asking from us here? We need to find how much H2O2 is present in 100 ml of the solution, right? That will be the percentage strength, or we can say percentage weight by volume strength. Now we have calculated the strength in the terms of grams per liter here. It is 60.52 per liter, right? So 1 liter H2O2 contains how much H2O2? 60.52. So 1 liter is what? 1 liter is 1000 ml. So in 1000 ml we have 60.52 grams of H2O2. Then in 100 ml how much we have? It will be 60.52 into 100 divided by 1000. So it will be 6.052, right? So 6.052 is the weight by volume percentage. It will be weight by volume strength, we can say, or weight by volume percentage of H2O2. So this is how we can easily find the all 4 questions asked in the part A of the question. Now part B says calculate the volume strength of 3.58 normal H2O2 solution. Now in part B we are given the normality, which is equal to 3.58. Now we know that normality is equal to molarity into n factor, and n factor of H2O2 is 2. So molarity comes out to be 3.58 divided by 2. So it will be 1.79. This is the molarity. Once we obtain the molarity, we can easily find the volume strength, that is X. So X will be equal to 1.79 into 11.2. So once you calculate this value, you will obtain the volume strength of H2O2 in the part B of the question, right? Similarly, this was a little bit basic question to have the proper clarity of concepts which are applied here. In the next question, it will be a little bit good one, a little bit more approaching towards the application of concept. So let's go through it. But again, before just directly going to the solution, I will hope that you will solve this problem by yourself. And once it is done, you will correlate your answer with the problem solution given here. Now in this question, what is it saying? That 56 volume strength and 500 ml H2O2 solution is kept in an open container, due to which some H2O2 is decomposed and it evolves 8 gram O2 gas. So basically in this question, 56 volume strength H2O2 is given to us. That is, the H2O2 solution which is given to us has the volume strength of 56. And what is the volume of that solution given? 500 ml. So we have kept it in the open. Because we have kept it in the open, some amount of O2 is released, which is 8 grams according to the reaction, and some amount of H2O2 is also H2 is also vaporized, right? Due to these changes, the final volume is reduced by 20%. The question is asking what is the final volume strength of H2O2. Okay, so let's solve it. Now we are given here 500 ml of 56 volume strength H2O2 solution. Since 56V is the volume strength, what is the molarity? Molarity will be 56 divided by 11.2. So if you solve it, it will come out to be 5. So the solution molarity is 5, right? Now we are given the molarity, we know the volume, so I can easily calculate the number of moles. It will be 5 into 500 divided by 1000, right? Because we know normality, number of moles is equal to molarity into volume. And we have calculated the volume in the terms of liters, right? So I have divided 500 by 1000. So available number of moles of H2O2 are 2.5. Now we know the balance equation. H2O2 in the presence of small amount of heat decomposes to give 1 mole of H2O and half mole of O2, right? So if we go by this balance equation, I can say that half mole of O2 is obtained from 1 mole of H2O2, right? If you go through the balance equation. Now the question says 8 gram O2 is released, right? So how many moles of the weight of O2 released is 8 gram, and how many moles are there in 8 gram? It will be 8 upon 32. So it will how much? It will be 1 by 4. That means the solution which is given to us will give out 8 gram of O2, which means 1 by 4 moles of O2. Now the balance equation says half mole O2 is obtained from 1 mole of H2O2. Then 1/4 mole of O2 is obtained from how much H2O2? I can calculate, right? According to the balance equation, that half mole is giving us half mole is obtained from 1 mole H2O2. Then 1/4 is obtained from how much? It will be half mole H2O2, 1 by 2, by simple unitary method. That means the solution which is given to us, when it releases 8 gram O2, only half mole of H2O2 is utilized. Then how much is remaining? Remaining is initial minus utilized, so it will be 2 moles. That is 2 moles of H2O2 are remaining, right? Now the question is saying due to all these changes, final volume is reduced by 20%. So if it is reduced by 20%, then how much is remained? The remained is 80% of initial. So remaining volume is 80% of initial. It will be then 400 ml. So final number of moles of H2O2 are 2. Final volume is 400. Then what is the final molarity? Final molarity will be number of moles divided by volume. So when we solve it, it will come out to be 5, right? So this is the final molarity of the solution. So if you try to understand, the final molarity is just like the initial molarity. Initial molarity was what? It was also 5. Now because molarity is same, the volume strength will also be same, right? So what is volume strength? It will be molarity into 11.2. So 5 into 11.2, and it comes out to be 56. So that means the volume strength of H2O2 has not changed. It remained same even after the volume is reduced by 20%, even after some H2O was vaporized or O2 was released, right? So I hope you understood the problem and you have easily understood the concepts which are taught you above. If you want to go through the video again, just go through it and enjoy the process of learning. Understand this concept properly because it is very important one. And in the light of same one, another important concept is about to come in the next video, which will be percentage labeling in oleum, which is again a very important concept, and the questions which comes out of these two concepts are a little tricky one, but very easy. So go through this concept, wait for the next video. Until then, keep on learning, enjoy, goodbye.